Well, welcome back from break. This is an experiment in talk show TV, something a little different to cap off the day of a super different program. As the program indicates, I'm Les Norford, and I'm one of the PIs in SenSem. And to my right, I have Professor Newkian Wong from the Department of Building in the School of Design and Environment at NUS. And then Marcus Kraft, who is a professor in the Department of Chemical Engineering and Biotechnology at Cambridge and directs Cambridge's program here, the Cambridge Center for Energy Efficiency in Singapore. And then Heiko Eit, who is a senior researcher and program coordinator for responsive cities in the Singapore ETH Center, the Swiss contingent, and our neighbors in the Create Tower. So we're here to talk about outdoor temperatures, urban heat island effect, thermal comfort. This might not be an existential threat, if you will, to the well-being of Singapore, as would be the availability of food or water, subjects we've heard discussed today. But it is important. It affects the thermal comfort and sort of heat balance of people in Singapore. Higher temperatures compounded by, say, heat storm effects or periods of prolonged high temperatures lead to health problems. And it also affects the overall livability of Singapore. The government has recognized that, and in its second phase of its Land and Livability National Innovation Challenge, there's a specific challenge for those submitting proposals to come up with ideas that would lower outdoor temperatures by 4 degrees C in housing areas. And one might say, first value, the only way you do that is to put a dome over Singapore and blow it all out to Malaysia or Indonesia. We'll hear from our panelists today whether they think there are more environmentally and politically benign ways of coping with that. The panelists here have been chosen with some care. Professor Wong recently co-chaired an international conference here on countermeasures to the UHI effect that was just earlier this month, and he may have something to say about what came out of that. Professor Kraft is an expert in carbon emissions from industrial processes, and I think others on the panel have concentrated more on buildings and less on industry. So we'll hear about energy flows and sinks in that area that may have some contribution to urban heating. And Dr. Eit has taken the lead in preparing a proposal to NRF that combines SEC, SenSem, and to create 3 Create partners to specifically take on a very detailed investigation of urban heating, its causes, and possible mitigation strategies. So I thought we'd give each of the panelists 5 or 6 minutes or so to say whatever they want, and then we may have a wee bit of discussion between us, but most of the second half will be open for whatever questions or comments any of us might have. So, Newkian, would you like to start?
Okay, still not quite sure what I want to say. Okay, thanks for the invitation to have this panel discussion. Perhaps maybe I just quickly share with you what I've done over the years in this area of urban heat island research, and perhaps some observations that I have made from the research. I started working on the urban heat island research since 1999, so it's about 16, 17 years. Of course, we started by looking at the overall urban heat island issue faced by Singapore by using satellite imagery. Now you see it everywhere, using satellite imagery for understanding the heat or the hotspots of Singapore. We also do very extensive field measurement in order to understand the heat distribution across the whole island. And we see that there's actually a very good correlation between the measurement and also the surface temperature that you can predict or that you can obtain from the satellite imagery. So with that, we get an overall understanding of the urban heat island issue. Based on our 2004 publication, the urban heat island intensity turned out to be around 4.5 or 5 degrees Celsius. Right? But there was a more recent study done by my colleague, Matthias Rolf from Department of Geography. His study shows that the urban heat island intensity has gone up to about 7 degrees Celsius. So it looks like we are fighting a losing battle. The urban heat island issue seems to be getting worse. Well, I guess we can understand that because of the very limited land we have to push for urbanization with more buildings, more roads, infrastructure, and so on. Definitely, this issue is going to become very difficult to handle. But of course, I have to say that the government agencies over the time has put in a lot of effort to do research, with the different tertiary institutions to look at this issue. I think that's a good thing. In the very recent Grand Call, we also see a lot of emphasis on this, specifically on the urban sustainability solution. There's a specific area on cooler climate Singapore that they want to address that. But of course, they put in the reduction of 4 degrees Celsius. To be frank with you, I really don't know how we can achieve that, except like what Leslie has mentioned. It's impossible. Based on our study, we find that, well, you can make use of, for example, trees, which can have some mean of cooling, and the reduction, very localized, could be maybe 3 degrees Celsius. So to achieve 4 degrees Celsius, I presume that 4 degrees Celsius is the average across the entire Singapore. That would be very difficult. So this is something, it's a huge challenge for us to achieve that. But anyway, over the years, we also developed some methods to predict the hotspots of Singapore. We have developed using GIS, that we can predict the hotspots for any new development. The more recent one, we can also link it up with a SketchUp, because we find that even though GIS is a very excellent tool that we can use for urban planning, for urban design, and so on, but somehow people still find it extremely difficult to use it for their work. So that's why we link it up with SketchUp. So because SketchUp, most people are very familiar, they can do the design very quickly. So now you can use the SketchUp to do your urban planning and design, and then with that, we develop a plugin that you can use it to predict the hotspots and so on. So there's one aspect in terms of prediction model that we have developed. Now, of course, we are also working with trying to link the urban model with the global model, the climate model, like WAF model, and RSM model, and so on. Okay? Because by doing the linkage, then you can understand what is the impact of climate change on the urban environment. And then at the other spectrum, we also try to link the urban model with the energy model so that we can understand how the urban model or how the urban environment impact the energy consumption of buildings, especially for Singapore, the impact of cooling energy. Then on the mitigation aspects, we look at different mitigation solutions. One would be greenery. So far we find that greenery, in fact, is a very effective measure for reducing the temperature because of the excellent shading. Okay? Though the cooling effect of greenery because of evapotranspiration, the knowledge is quite limited, and how effective actually evapotranspiration can translate to reduction in the air temperature, this is something we still need a lot of investigation. Because we suspect that in the very extreme hot weather we have here, the greenery can undergo something called stomata suppression that results in the reduction in the cooling, reduction in the evapotranspiration, and therefore reducing the cooling effect. So this is something that we need to do more research on. Currently, we have a research that's ongoing, trying to really measure the evapotranspiration of trees. Literally, we have to put the tree on a weighing scale and then do the measurement in terms of loss of water over time to understand more about the evapotranspiration. So greenery, yeah. I find the greenery, the most effective aspect is the shading. I think in this kind of tropical environment, I think you know shading is really a very, very important aspect. I think for those who are driving, you know that if you park your car under the shade of a tree or without the shade, it makes a lot of difference, even maybe 15 minutes later. So shading is really very important. Of course, like what Leslie has mentioned, recently we organized an international conference on countermeasure for urban heat island. In the conference, we see a lot of advocates on the use of cool roof, cool coating and so on. Now, this is still something that we really need to have more study in terms of the effectiveness over here because of our high density, high compact kind of city environment. Whether such application could be very effective. The issue of reflection to your neighbors, reflection of the heat, and then sort of get trapped in the urban environment. So all these are important issues. Though we are also looking at some very interesting solutions like retroreflective material that can reflect the heat vertically upwards rather than downwards. That can help to minimize the heat trap. Yeah, so these are just some of the very quick overview of what we have done. I think overall I can conclude that in the context of tropics, maybe for Singapore, especially in the case of Singapore, shading is the most effective one. And secondly, you need to promote ventilation to have effective channel of wind. These are the two key observations we have made. Yeah, of course, there are other details that we can discuss later. Yep, I think that's what I can share.
So, hello everyone. My name is Markus Kraft. I'm from the CARES program that's sponsored by NIF through CREATE. So CARES means Cambridge Centre for Advanced Research and Education in Singapore. We've just changed our name. We used to be just Centre for Energy Efficiency Research in Singapore. So we have a sub-program of which I'm the director. This is called Cambridge Centre for Carbon Reduction in Chemical Technology. Now, this is all about heating up of cities. So question is, why am I sitting here? So let me try to motivate this a little bit. I just had a visitor a couple of days ago, Gerhard Schmidt from the ETH Zurich. And so they are part of a program called Cooler, Calmer Singapore. And so we presented our work to him, and in that discussion it became clear that, at least that's what he said, 60% of the heat that goes into Singapore is actually from Jurong Island. Now, whether or not this is true, okay, what I can say with great certainty, there is a lot of energy consumption in Jurong Island, okay? So energy consumption today means mostly production of CO2 from fossil fuels. And of course, that is a problem in general. So I guess if we can address the additional heat problem, then in a way we also address the main goal of our program, okay? So now the question is, what can we do about addressing this heat problem or the CO2 emissions. And this is the main purpose of our program. And let me just quickly explain to you how we try to attack this problem. So we have 4 sub-programs. In the first instance, we are interested how can we capture CO2 from a combustion process. Then once you have captured it, how can you use CO2 and turn it into something that's a bit more useful? And then the second part of the program is then, okay, if you have CO2 and you want to turn it into something useful, it'd be very handy to have some hydrogen. Okay, so we have a number of people who try to understand how you can use electricity to turn water into oxygen and hydrogen is one key thing, or to turn CO2 into another useful product. And then the third part of the program, this is a bit where I'm a principal investigator, is to look at the whole of Jurong Island in terms of a systemic way, so what we would call it a process system engineering way, and that is now very closely connected to what urban planners do, because you could look at a city with the houses as a chemical plant, okay? So you may have a central heating, okay, where you use energy to run your air conditioning systems and the power in the heating, use power to run your fridge and other appliances in the building, and you have infrastructure, water. So in a way, although of course it's not a chemical plant, there are lots of elements that you can actually look at, and once you then represent these elements in terms of eventually in mathematical equations, then of course you can use optimization in order to run processes more cleverly to reduce the overall amount of energy needed for the whole building, right? So that's what you can within the building, but of course you can also, once you represent the building in a computer, you can use this in conjunction with CFD software, that's computational fluid dynamics, and I'm sure in your research group you do exactly that. And there are a lot of technical questions related to how to do this properly, because it's not so easy. You get boundary layers and mixing, and so it's not quite as straightforward. So there are a lot of research questions in its own right. But then, so you can, just to summarize, you can look within the building, the actual technical aspects of it, and also the external flows, the transport heats, that's also important. And all these elements we look at on Jurong Island as well, right? So I guess the research in that respect is actually not too dissimilar. So, and finally, the fourth part of our program, just to describe that, is about smart grids, how to use electricity in such a way that you can combine electricity from, say, solar cells, which of course can also play in its own right a role in cooling down surfaces, especially roofs and so on, and how to get this electricity and put that into the local grid, and how to do this cleverly. And so an underlying aspect, so these were the four streams of our program, but an underlying aspect, of course, is that no matter if you do only simulations or if you start measuring stuff, the moment you do it, you have tons and tons of data. And the question is, how do you interpret this? What can you learn from it? And so there are a lot of research questions that we need to address to get best value out of this data. And I think that's all I have to say for now. Okay.
I'll have some questions later.
Okay.
Thanks. Hello, everyone. As Leslie already introduced me, my name is Heiko Eid, and I think before I start talking about Cooler, Calmer Singapore, let me just give you a brief background on who I am. Many years ago, actually, I started off as a computer scientist, and then sort of during my PhD became a computational scientist. So basically, I'm using modeling and simulation to study systems, or basically the world that surrounds me. And I joined the Future Cities Lab last October, and now I'm surrounded by a lot of designers and architects, urban designers and architects. So, which is very interesting because if you come from a very technical engineering kind of background, and then now you're surrounded by designers and architects, that's actually very interesting. So at FCL, one of the things that I do is I coordinate one of the 3 thematic research clusters, in this case on responsive cities, and I'm also heavily involved in the Cooler, Calmer Singapore initiative, which FCL has already been involved since, I think, 2012. So generally what we do at FCL is it always goes back to urban design and architecture, and the question is, okay, how can we, for instance, improve livability by means of urban design, changing the urban design, or also the building design. And that's, of course, also very important in the context of the Cooler, Calmer Singapore project. So the Cooler, Calmer Singapore, as the name suggests, is about cooling, so that refers to urban heat islands, but also about calming, basically reducing the noise pollution. If you can address these two, then that's already contributing quite a bit to increased livability. Now, I think today the focus is on heating or on urban heat islands, so I'll skip the noise part. So there was this idea, or this target of reducing the average temperature in Singapore by some degrees Celsius. To me, this is actually not so meaningful. But I like to think more about what matters is livability, and we need to think about thermal comfort, especially at those places where it matters. In other words, where the people are. So, for instance, if you talk about average temperature, average over Singapore, that includes areas like Jurong Island or also the airport. And quite frankly, I don't care what the temperature is at Changi Airport, but I do care a lot for how the temperature is where I live. So to me, it's not so much about like having this target, okay, we want to get the average down by 4 degrees, but what I would like to look at, and this is also what we try to do in this Cooler, Calmer Singapore, looking into different areas in Singapore, and then really see how can we, with urban design measures, or also generally design measures, how can we improve the thermal comfort there. And what's the potential there? In some area the potential may be 1 or 2 degrees, in other areas the potential may be higher. So I think just talking about this one fixed number doesn't make so much sense to me. I already mentioned that my background is in modeling and simulation, so of course in the Cooler, Calmer Singapore initiative, or in various projects that we also have in FCL, we use a lot of models and simulation to help us better understand this. So in one of the things that we specifically also look at is really also the anthropogenic heat sources and what kind of impact it can have. So for instance, in the past, we also considered traffic. I think about 20% or so of the energy consumption in Singapore goes into transport, and most of it into traffic. And ultimately, this energy is at some point converted into heat. And the question was always, okay, what's going to happen? What's happening to this? What's happening to all this heat? And also, does it make a difference actually to thermal comfort? It may or it may not. So it's not so clear. And we basically wanted to get an idea for this. So we started building models. And of course, building models is always also sort of limited by data. So getting the data is of course kind of difficult. But there are also other problems. So this work is still ongoing. And yeah, so we are not the only ones, of course, who work on models and simulation. I mean, Professor Wong, for instance, they use models, Professor Kraft as well, and I mean, I think pretty much everyone who is doing research on urban heat islands is using some form of model. I mean, A*STAR, for instance, is also very active. So for us, it's kind of like shifting a bit because we realize that, of course, we can come up with another model which is maybe better in certain aspects than someone else's model, but I think what we are more interested in is this what we call design loop. So for us, it's really the question, okay, how can we use existing models, or perhaps also some of our own models, and then basically package this in such a way that an urban designer, for instance, can play around with different scenarios. So, for instance, one example could be that it's about redeveloping or planning a new area, and then the question is, okay, how do we place the buildings? What impact would it have if we place buildings in this way or in another way? What happens if we change the facade? What if we add more greenery, and so on? So there's basically a couple of design questions that have some impact on urban heat islands or on thermal comfort. And it would be nice if we have this kind of tool, if you like, that allows urban designers, or basically the practitioners, who can have an impact on how these parts of the city are developed. What happens if they do certain things? So this is one of the things that we work on, so I already mentioned modeling and simulation is basically using technology that can help us to better understand what's going on. But I think one of the things that I should mention is we've had plenty of discussions with local researchers, but also with people from the agencies. And one of the things that we realized is that actually the problem isn't necessarily that the problem isn't that, okay, we don't have a model for this, or we don't understand this or that aspect of the overall problem. I mean, there are still a lot of question marks, otherwise we wouldn't do any research. So there are certain things which we don't know yet, but there's also a lot of things that we already know. But when it comes to urban heat islands, I think one of the problems is really that if you really want to have an impact, then the question is who is going to oversee all this? And especially when we spoke to the agencies, they also agreed with, so who is the one who's responsible for it? There is no Ministry of Urban Heat Islands, and there will be no such ministry. And also there is no single agency here in Singapore, for instance, that is solely responsible for this. It actually touches several agencies, and then actually it's really a problem getting them together, and then I guess also on their side to figure out who is taking the lead in this. And Leslie mentioned a proposal that we are currently working on, which is with the NRF, and this is actually in this proposal we're actually trying to get at this problem that we really want to get the different key players in Singapore together and talk to each other, and perhaps devise a way or a roadmap that can help really addressing this problem. So I think the focus is shifting a bit away from the technology, more towards the practical aspects, and I guess policy making in a larger sense, because at some point someone has to make a decision about these kind of things. So I think this is it from my side. As I said, I think the problem is really not so much of a technical. It's not so much of a technical problem. It's really it requires input from multiple partners, multiple agencies, and I think this is what makes it very interesting.
Well, our group also does some modeling, but I thought just for a few minutes here, I would try to channel Marcus and look at have a systems level view of some of the issues. And I shared a little of this with some people in a technology and policy workshop earlier this week. So. One thing I've learned from the kind of modeling we do is just to think about this as sort of an energy balance, as one would do, say, in an industrial process. And the heat inputs for that lead to urban temperatures are only two. It's net solar energy and anthropogenic heat. And then where it goes is sensible and latent heat flux, storage and building materials of the ground on kind of a diurnal fluctuating basis, and a little bit of advection. Temperatures again are the outcome of that, and the heat flows are largely 1D. They're vertical, so the heat island effect can be very local, and Heiko made a point of that, and you can also. They can vary a lot from place to place. You can mention 4 degrees. Matthias had seen something as high as 7 along Orchard Road. So those of you who go shopping on Orchard Road in the evening, it's going to be a lot hotter there than it would be up by the zoo probably. one thing we found in our research, Zhang Li has done these simulations, is that more than, in commercial industrial areas, more than half of the urban heat island effect is associated with anthropogenic heat. If you turn it off in the models, it goes down by a little more than half in commercial industrial areas. And the other half is due to just sort of the morphology of the buildings, their density, trapping of radiation, and the building materials, whether they're reflective or vegetated or whatever. So mitigating the urban heat island effect requires either some attention to the heat inputs or to the dissipation, which was the ventilation that you can mentioned. And so for the solar, just my thinking about Singapore, having spent a fair amount of time here, it seems that there's no one size, there's no sort of agreed on, and maybe the need for a little more research, attitude on what to do with it. You can reflect it. You can use plants to convert it to latent energy and sort of lower the temperature effects of that. You can use it for PV and make electricity, and the government has said as prices come down, maybe there'll be more of that. Or you can do nothing, in which case it's absorbed on roofs and walls and so on, and becomes a heat input not only for buildings but the urban environment. It's a lot of energy. The average in Singapore is about 130 watts per square meter, just average over 24 hours. It's about 250 watts per square meter globally, and then cloud cover here, you get to about 130. The average energy consumption in Singapore is about 25 watts a square meter, and that 2/3 of that is industrial. So when Gerhard Schmidt tells Marcus that Jurong Island is something like that, he's right. And so we could cover Singapore with PV, and Singapore would be net neutral on energy. That's not going to happen. PV at say 20%, but I think at island-wide, not thinking maybe at a system level enough about what we do in certain areas has probably means that we're not making best use of a large carbon-free resource. Some of you heard me mention a material that's come out of Stanford, and I'll mention that again. Buildings, we coat them. We coat them with titanium dioxide to absorb certain pollutants. We can have reflective materials. They're still typically hotter than the air temperature in the day when the sun's on them, and that leads to thermal comfort problems. Heiko talked about comfort outside rather than temperatures at Changi. It's where you live that matters, and air temperature is just one part of that. Radiation on the body is another big one. Shading was what Ken mentioned. Surface temperature is also a part of that. Walls heat up. The Stanford material, sort of a multi-layer photonic material, reflects about 97% of shortwave radiation and emits in the 8 to 13 micron atmospheric window. Clear skies in Palo Alto, we don't have as much of that here, but its surface temperature can be 4 to 5 degrees C cooler than the air temperature. It can radiate heat to the atmosphere, even in the sun, which is pretty remarkable. Now, is that more than just a coupon on a roof in Palo Alto? Not yet. Is there some promise of that with more sort of nanoscale photonics research? You bet. So building scientists may have a better palette of materials in the future. Anthropogenic heat. Heiko said he wasn't going to talk about noise, and maybe this isn't the part, but I think of cars as a source of noise and heat and pollutants, and boy, it'd be great to electrify all of them, and other vehicles as well. But for vehicles and buildings, I think there's the one thing that's going to help from kind of a policy governmental action point of view in reducing anthropogenic heat is Singapore's commitments to climate change through the COP21 process and its intended nationally determined contribution, INDC, which will reduce, look at my notes, emissions intensity per GOP by 36% from 2005 to 2030. Hope to stabilize emissions peaking at 2030, and reduce emissions by, at that point, emissions would be reduced by 16% below 2020 business as usual. So that reduction in CO2 emissions, much of it presumably will come from efficiency, and that will be good from a kind of a heat island point of view. Electric cars, why would we want them from a heat island point of view? Because there's less heat that goes into the urban canyons. The electric motors are more efficient than IC engines. The conversion from fossil fuel occurs at a power plant where there's some hope of either capturing and using some of that waste heat, or at least getting rid of it in a way that is not local. It's not in our street canyons. It's not where Heiko lives or I live. So just to kind of finish up this minute or two, are there similar options for buildings? And I want to mention two. I thought Professor Lienhardt's talk was super interesting, and it got me scribbling a little bit. He's a membrane guy. And one thing that he and I and others hope to do here, Professor Chua in mechanical engineering, is use membranes for dehumidification in buildings. So Professor Lienhardt noted that the thermodynamic limit to desalinate water is about 1 kilowatt hour electric per cubic meter. And the best thermal systems maybe are 10 to 15 kilowatt hours electric per cubic meter. The membranes are a lot better than that. How do we dehumidify buildings now? We have either cold refrigerant undergoing a phase change or chilled water in pipes, and we condense water on surfaces just as you would have on this if you took it out of a fridge. If you look at the energy of heat of vaporization of water, 2260 kilojoules per kilogram, and convert that into Lienhardt units and have a reasonably decent air conditioner, the number works out to about 150 kilowatt hours electric per cubic meter of water, which is a huge amount relative to anything he showed us. And so membranes can do better. You can use them as molecular sieves. You can draw water molecules through them and exclude O2 and N2 and not pay for the heat of condensation. There is pumping power. It's not for free, but it would be a lot better. And just two very last points. One is on chilled water. Professor Chua, my colleague, would like to not provide electricity to cool buildings, but provide chilled water instead. Now that's an infrastructure problem. It means that the big tunnels that Professor Whittle and others are concerned with, subway, water supply, wastewater, electricity, would have to be extended to do something else. What can one do with that if you provide chilled water? Well, then the heat from the buildings is taken out of the local area. Cold water comes in, warmer water comes out, and it goes someplace else. So you not only get rid of the mechanical inefficiency that goes into the street, but the heat as well. Now, it still has to go someplace, whether it's dumped into the sea or captured and somehow low-grade heat is used, but it's out of where people live, and that alone, I think, would help a lot. And finally, for Marcus, so maybe I'll ask you a question now, and then we can open it up to the, open up the audience. I have a little bit of Jerome envy in a way, or I covet your processes. One thing Gerhard Schmidt mentioned to me was, and Heiko, you may remember the number, there are LNG plants there, I believe, and Singapore is ingesting LNG and will use more of it for producing electricity, or maybe the LNG plants are elsewhere. The question is, what happens to all of that cool energy when it's vaporized? Is it being used now? Professor Smith said something like it could be used to cool some very high percentage of all the buildings in Singapore if it were used, captured for that purpose rather than sort of vaporized or dissipated in heat exchangers. So do you know anything about that? Maybe in the buildings area use your use waste cooling.
I don't know any details about the LNG plants, but what I can tell you is that using low-grade heat is one of our key means to get the overall energy consumption down. How one would, there is potential, there is not only heat, there is also low temperature from some processes that can be used. One problem we have is that we basically have to invent everything because all the operation on Jurong are classified. We have modeled some of the plants on Jurong, but at the moment, because we are still, I would say, only 30% into the overall project, only a smaller fraction, and we haven't modeled the LNG plants yet. That's why I cannot give you numbers or details, but what I can say is that there is definitely potential to use some of the stuff. Although one has to say that I know that EDB had quite a number of studies to reduce, to make people collaborate. I know SEMCO and JTC also look on a regular basis into synergetic effects. Now, how much they have actually done it, I cannot directly comment.
Well, just to finish up on that, I think when we talk about systems level approach, it's often just Jurong or it's a building and it's rarely all of it together. So 50 degrees C, which is pretty low grade heat, is enough to regenerate desiccants that can also be used to dehumidify buildings. And I'm sure there's a lot of heat at that temperature running around Jurong. And so is it cost effective to have an infrastructure use it? I don't know, but I think it would be worth considering, taking a chemical engineering approach to the whole island at some point. Are there questions, comments from the Marilyn?
Yes, so thanks a lot. I have a very generic question. So in terms of mitigation strategies for the heat island effect, which of those that were mentioned, we've heard about trees and urban design and shading and so on, which would be specific to the Singapore context, or which would work particularly well in Singapore compared to other, where some of them are quite generic. So when do we really target the Singapore context?
Maybe let me try to answer that yet. Yeah, that's a very good question. There's also a research question that I've been working on. Personally, based on the huge amount of data that we have collected based on the actual measurement, we feel that greenery is really playing a very important role in mitigating that because of the two properties I mentioned. First is the shading, the excellent shading. The nice thing about trees is that we have also done the measurement on the leaf of the trees and so on. We find that the interesting thing about trees is that while they shade the solar radiation, the temperature of the leaf does not go up as high as what you can see in a concrete surface or in a masonry surface and so on. That's the nice thing. It provides excellent shading, but at the same time, it does not create very high surface temperature. That could be a problem. That is perhaps because of the very special property of greenery. And the other one, of course, is the cooling effect due to the evapotranspiration. Like I said, that part we still need to understand more about how effective it is because of the stomata separation due to the extreme weather we have here in terms of high temperature and so on. So that is the conclusion I can say in terms of greenery. Other mitigation measures like cool coating, cool roof, and so on. Though we have done some measurements here, we find that we really need to, actually they are extremely low cost solution. You know, basically you're just painting the surface white. In fact, that itself is good enough, you know. Of course, you have to look into the issue of durability, you know, how long it can last, especially our roof here. They are primarily the surface, we call it service roof that you're subject to a lot of wear and tear because of the human traffic and so on, and also the weather here. So that could be a very low-cost solution, but somehow that is something that has not been tried out very extensively. Our government keep on having a lot of reservation in terms of how effective is that, primarily because of the issue of reflection. You know, when you make it highly reflective, whether there's an issue of glare, there's an issue of heat affecting your neighbor. Now, especially if you want to try it on the wall, they have a lot of concern on that. In fact, BCA recently implemented a limit on the reflectivity of the surface. So that actually is counter, you know, the mitigation we want to have for urban heat island. So I have highlighted this issue to them also. You know, while you try to limit the reflectivity on the surface, that will reduce the glare issue, but you know it can result in a high urban heat island problem. But of course, they say, oh no, glare is a more important issue that we should address, yeah, because they receive a lot of complaints from those occupants and so on because of the reflection from the facade and so on. So I think that part really requires a fair bit of research and study to understand that. Like I mentioned, now we are also looking into things like retroreflective material. You know, instead of reflecting it downwards, it always reflect with respect to the angle of the sun, so that hopefully can minimize the heat built up. The other important aspect is really ventilation, and that is also the most challenging part. You know, how to design your city, how to design your urban environment so that it is well ventilated. This one you really need to work very closely with the government agency, especially like URA, to make your building more permeable, more porous to wind and so on. So for example, we advocate the provision of void deck, you know void deck, huh? By having this void at the ground level. And we study some building, we find that that's really very effective, you know, to channel the wind through the void deck so that the wind can penetrate deeper into the urban environment. So these are the things we need to work. So I hope I answer your questions. Yeah?
Well, you can, if void decks are a good thing, why don't we have them in Punggol or even Casa Clemente close to where you and I work?
If you don't mind. Yeah, in fact, I asked the same question to our HDB, you know. The answer has always been that, you know, we want to utilize those very precious space we have, you know. So now you can see more and more of those void. In fact, our old generation HDB flats, they all have void decks, and those are excellent design to channel the wind. In fact, our studies show that not only the wind can channel through the void deck and therefore improve the thermal comfort for the pedestrian, for those at the ground level. For those lower units, you know, those units that's just immediately above the void deck, or few levels above the void deck, they actually improve the ventilation as well. Because as the wind channel downwards through the void deck, it also serves to channel the wind through the lower levels. Because over here, if we don't have that void deck, you find that the lower level units tends to have poorer ventilation because of blockage and things like that. So we find that void decks become very useful in channeling the wind not only down to the pedestrian level, but also serve to improve the ventilation at the lower units. Now we are also trying to advocate by having, you know, mid-level sky gardens and things like that that can also serve to improve the overall permeability at the urban level, at the city level.
I wanted to talk both of you about temperature. And I was asked, is humidity also factoring in sort of comfort and livability? And if so, is that engineerable? And are there trade-offs when you use evapotranspiration in terms of, you might decrease temperature, you increase humidity, and is that better or worse for comfort and livability?
Is Jean-Jane here? Yes. Jean-Jane, you want to say something about that? Or I have the mic. If there's a mic there, it's a good. The answer is it's a good trade-off. But go ahead.
Hello. Yes. Yes, it's really a trade-off between the temperature and humidity. Based on our recent study, if we implement the so-called green roof system in all the commercial and industrial areas in Singapore, we can reduce the air temperature by more than 1 degree and add a little bit of the relative humidity. And the total effect, we use a thermal comfort index to calculate the total effect and found that the total thermal comfort index is reduced rather than increased.
Sorry, you don't mind, I add in a comment on that. This is indeed a very, very interesting question. When you promote more latent heat, converting from sensible to latent heat, you add more humidity to that. I think there are two aspects of that. First is in terms of the impact on energy. Of course, there could be an impact in terms of energy, though overall the energy balance could be the same. But you just look at in Singapore context when you talk about air conditioning. Sometimes you may wonder, especially for those who are not from Singapore, when you walk into a shopping mall, you need to wear a winter jacket after 10 minutes, 20 minutes, extremely low, the temperature. And very often when you talk to the engineer and ask them why you need to have such a low air temperature, the argument has always been, it's the humidity that we need to address, And in Singapore, you're not allowed to reheat. Our regulation do not allow reheating unless it's for a very special situation that the humidity has to be strictly controlled. So therefore, you need to bring the air temperature to be extremely low to promote condensation. And you cannot allow to reheat, so that's why the air temperature. So that could be a big issue here. But if you are to look at from the outdoor perspective, of course in this case about thermal comfort. Interestingly, we have done a fair bit of outdoor thermal comfort research, including indoor thermal comfort research as well. In the tropics, also specifically for Singapore, maybe I should at least speak about Singapore, though I would say that it should be the same. We are more tolerant to higher humidity. In fact, based on the data that we have collected over the years, when we analyze it, we find that humidity does not play an important role in affecting thermal comfort. It is really the radiant heat and also the wind and to some extent the temperature that is very important. Humidity, unless it reaches about 80% and above, then we start to really feel the discomfort. Otherwise, actually, humidity actually plays a very little role in terms of affecting our thermal comfort. Well, I guess maybe you could understand that. We have been staying in this very high, humid environment that we sort of get adapt to it or get adjusted to this kind. Yeah. So therefore, in terms of thermal comfort, humidity actually does not impact that much in terms of the level of comfort as compared to the other parameters. Yeah. Okay.
Jim.
So I'm going to pick up the system engineering theme and ask if instead of just designing an individual building to improve ventilation, if you could actually design your buildings, place your buildings, choose their height in the city could you improve, how could you improve, what would you do to improve the city's interaction with the environment to improve this urban heat problem, ventilation problem?
Actually, that's a very good point. I mentioned earlier that what's important is the design and the urban design, and then of course you can look at the individual buildings, but the problem is that if you just look at one component of the system, in this case it's one individual building, you can look at it and you may take some measures, maybe having these void decks, and then you get more ventilation and all this. So it's all nice, but important is also how I mean, a city is a complex system. So you have a lot of cases where you make one change in this part and it affects something on this part. So urban design here is not, there's no exception there. So I think you need to look at it from a holistic point of view instead of just looking at one particular building or one particular block of HDBs where you want to make some changes, but really consider the larger implications. If you change the design in this way, then this may affect some other parts of the city as well. And again, modeling and simulation can help there, although there then you get this problem that you can't have this super high resolution simulation of the entire city. So that's actually one of the problems that we have as well. We often get asked, okay, you know, this is great, but now can you do this for the whole city, you know, simulate the whole city? And that's obviously, if you, no, we can't. So it basically goes into the direction of multi-scale modeling. Personally, I like to see the city really as a complex system. So it's really looking at the impact that small changes can have on the overall system. And I think important is that we have these tools that make it also possible for urban designers who may not know much about, I don't know, evaporation or all these physical processes, these underlying physical processes. But we need to somehow package all this knowledge that we have, bits and pieces here and there, somehow package this in a way that they can have access to this information, and then they can make more informed design decisions. It's actually also one of the things that we look at the Future Cities Lab as part of the responsive cities, is this idea of big data informed urban design. So it's really how can urban design be better informed? I mean, there's so much data and so much stuff available, so many models, but how can all this be sort of accessed by an urban designer to make better informed decisions? So I don't have a precise answer to how this could be done, but this is basically the approach that we are taking.
John.
So I would like to follow up on that question, because it seems to me that about 10 years ago, some of us were here listening to almost the same type of challenge. It's a difficult challenge, but I wonder if you could comment on what progress has actually been made in Singapore to address this particular challenge that Professor Bellingham has brought up and others have brought up, and that is the systems approach.
I can not fully answer this question because I was in Singapore 10 years ago, but I wasn't involved in actually creating an existence. But one thing that I found very, very interesting and very impressive as sort of a development is that I mentioned earlier that the problem is that you don't have this one agency that's responsible for this, right? So you need actually more collaboration between the different agencies. And in the last general election in Singapore, they actually, when they announced the cabinet, they also announced these coordinating minister roles. And I found this very interesting because at least my interpretation of this is that on a very top level they have understood that the different ministries need to work more closely together and collaborate. I guess the role of these ministers is to coordinate the activities. And I think this is a sign that they have understood that a lot of these big, hairy problems that we have really need coordination between different agencies and different entities. So in that sense, I can see that there's a recognition of these kind of problems, and that they're making some structural changes at a very top level to sort of address this. Now, I don't know in practical terms how long it will take until this will really have some effect. That I don't know, but at least I think that was an interesting development.
I hope I'm not speaking too much. Let me try to share with you. After doing research in this area for quite a number of years. I remember when I started my research on UHI in 1999, no one knows about what UHI is about. The only colleague is from the Department of Geography, Matthias Roth, who did something on that. The government agency has no idea what UHI is about, and they don't care too much about what UHI. In terms of planning, urban planning, new development in an area, in an estate, and so on, no consideration at all in terms of wind, in terms of temperature, and so on. But I have to say that over the years, at least maybe 5-6 years ago, the agency now pay attention to this. Though I have to say that to effectively integrate the two in terms of the urban planning and then how tools could be used to support their planning, to support their design is still a challenge. To develop a very simple tool that they could use so that with the click of the button they can generate some useful information that can help them to plan, to design and so on is very, very critical. Now, even if you are to look at currently the tools that are available, let's just say CFD for urban ventilation study, it is extremely difficult to use that to support the urban planning design, urban planning and design. I remember we had a project with URA. They expect us to do a modeling covering about 4 kilometer radius. And then that time we worked with A-Star using their CFD modeling. Each iteration takes about almost that time, in 2008, it takes about more than a month to just get one iteration results, And URI look at it and say, I want the result tomorrow, can you give that to me? It's impossible to provide that kind of support. So I think there are still some challenges in terms of technical solution and how that can be effectively integrated with the planning process. I think there's something that we are still trying to see what can be done. Earlier on in my introduction, I mentioned that we even, when we make use of GIS, which we assume all our various government agencies should be very experienced in using that for the urban planning and design, but we find that no. When we pass the whole GIS model to them and say, yeah, now you can use it. We even develop a plugin within the GIS so that they can understand the hotspots and so on. They say, no, we don't know how to use it. So because of that, we have to develop another simplified model using SketchUp. So you can see there's still a lot of barriers in terms of integrating what we can produce as researchers with the actual planning process. Yeah. So, but I can see that there are a lot of interesting study that has been working on this area, hopefully to more effectively integrate that. So hopefully by then we can look at it in a more systematic way, Yeah. So that's my...
Andrew.
So one thing that you guys have really addressed, Singapore has grown enormously in the last 10 years. A lot of buildings going on at the moment, obviously not respecting detail and effects. It strikes me that the question I would want to answer is where is the best priorities to retrofit what we've currently got? What technologies are most appropriate to help us address some of these problems, given that we're so urbanized now?
I can offer only my view. I think maybe it doesn't help so much with the heat, but I think one thing that would really significantly increase livability is by really replacing the vehicle fleet with electric vehicles, because you're really killing several birds with one stone. They are more energy efficient, but maybe more importantly, they are also producing a lot less noise. And I mean, there's different factors to it. I mean, the engine noise is almost zero with electric vehicles. Then you have the friction of the wheels and the tires on the road, and of course also the wind noises, which typically at higher speeds these actually become more important. So, but I've actually experienced this firsthand. I lived very close to an intersection at the main road, and you really get these enormous like noise peaks whenever the traffic light turns green and everyone's accelerating. So this could perhaps be one change where it could make a noticeable impact in a relatively short period of time. I don't know, but again, it's I guess up to policy making. But I think in Singapore you have this unique instrument of a COE. So I think at least in theory they have a possibility to steering this towards electromobility if they decide to do so. So at least to me this might be one way of addressing this.
Maybe perhaps I just add on. I think anthropogenic heat is something that we can really address. And it could be effective, you know. We have also done some study doing the measurement along the Shenton Way area. Our studies show that during the peak hours and the off-peak hours, especially during the weekend, we have done the measurement. We find that the temperature difference could be as much as 8 degrees Celsius. We are very, very surprised to look at the result. So it shows that the anthropogenic heat that's generated by the traffic could be tremendous. So that's really something that we can do about in terms of controlling our traffic, you know, in our urban area, in our CBD area and so on. But in terms of building, I think your question is more about retrofitting of the buildings. What could be done to that? Yeah, in order to mitigate the UHI and so on, that is really a very big challenge. Especially, for example, how are you going to retrofit your existing building stocks to improve the urban ventilation? That is an extremely challenging issue to address, you know. Or we may be able to do something about our facade, you know, and so on. Especially you look at Singapore, the tremendous amount of glass facade that we are using, you know. And in the earlier days, the kind of glass facade is just not energy efficient at all. You know, the tremendous amount of heat that is being absorbed by the glass facade, and then how it impacts our cooling energy consumption, and ultimately how such waste heat is being thrown out into the environment. So perhaps that's we can expect that we can really do something about it to make it more energy efficient, especially for our glass facade. Yeah. All right.
Well, I think both of those are good ideas, and for larger buildings, let's say Orchard Road or commercial areas, I think more efficient HVAC that would address the dehumidification is possible. Maybe not so much at individual levels. Harry, you had a...
Yeah, I was just relative to Andrew's question and the greenery question. I mean, it would seem you could plant trees, but of course there isn't room in many places. Is there any effectiveness in letting lianas grow up the sides of buildings, covering them with vines, which you might be able to do in places even where there isn't room to put trees? And would that help?
He's done some work on rural greenery.
Yeah, I'm the culprit in doing. Yeah, okay, maybe let me quickly explain why we try to sort of promote the use of vertical greenery, though now it is completely out of control, I have to say that. Of course, we have been trying to promote the use of green roof, and our studies have shown that green roof, in fact, is very, very effective in cutting down the heat gain into the building, in reducing the surface temperature. For example, our studies show that just a very simple green roof, the surface temperature reduction can be as much as 30 degrees Celsius. Well, I think you can understand why, because our solar radiation is so strong, and then our angle of sun is so high up most of the time. So therefore, greening the roof is really a very effective solution. But the thing is, our buildings are getting very tall, you know, and then the area that we can use it for greening is become very small, you know. That's why the government start to ask, what can we do further than just greening the roof. We have huge amount of walls, you know. Why can't we green the walls as well? So that's how this vertical greenery study starts to come in. And then of course people start to innovate and come with all different types of green wall system, you know. Some of it are just too expensive, and to me I find that they are not effective at all. So that is a problem, because when you talk about greening the wall and greening the roof is a completely different thing. Yeah. For roof, it is fairly simple, but when you want to green up the walls in a vertical manner, it's very, very challenging. Your irrigation issue, yeah, your media to support the growth of the plants and so on. You know, when you do it this way, plant when you put it this way, no problem. But when you put it in a vertical manner, they'll go haywire, you know. And then maintenance, yeah. How do you ensure that the maintenance of the plants are done properly? Singaporeans are very, very particular. Yeah? When they grow very well, they overgrow, they get very wild looking, they don't like it. They say you must manicure it, you must trim it nicely. So that's also another problem we are facing. Certainly, I totally agree with you. A simple solution like having those creepers, you know, they just creep out on the walls or creep out on the wire mesh. Simple, effective, and very easy to maintain. That should have been the solution, you know. But the more worrying thing that I see over the years in terms of use of green wall has been, you know, because BCA promote the use of green walls, they have marks or they have points awarded for the installation of green walls. But they just specify, if you're a green wall, I give you 3 points, and that's it. They don't care about how you install your green wall. So landscape architects start to innovate and do also a green wall installation that is completely useless in terms of mitigating the urban heat island. It's purely for aesthetic. And worse, some of the green wall systems are installed in such a way that you need a lot of energy to maintain. So instead of reducing the urban heat island, instead of reducing the energy consumption, you put in more energy to support that. I think, not to mention the name of the building, you see huge green walls on the internal part of the buildings, you know. You know, the amount of light that they have to provide in order to ensure that the plant can survive well. We did a quick calculation for that. My goodness, you know, that is just not sustainable well. So these are the problems we are facing also. So we have been in discussion with BCA. Perhaps, you know, BCA should come up with a more detailed guide in terms of how green wall should be installed, and prove that, you know, such green wall can be effective in reducing temperature, in reducing energy consumption, and so on, rather than, you know, just allow them to install and then get the points. So these are some of the observations I can see here. But yes, precisely a simple solution like having creepers on the wall is good. I think it can serve the purpose very well. Yeah. Okay.
One more, the 5-3. Yes, Dr. Ray.
Referring to Andrew's question earlier about ventral fitting, I just wanted to note that the Berkeley program, the Civil Best program on building energy efficiency, actually has a very explicit goal on reducing, for retrofitting buildings, reducing energy consumption of buildings by 50%. And there's been enough progress that over the next 12 months, the BCA will be installing the range of techniques they have proposed into the zero energy building that the BCA has. That's one experiment going on.
Well, I could also, picking up on that, I could call attention to the building that FCL worked on as well, the World College building near the CREATE campus that has a retrofitted HVAC system, does heat recovery on ventilation and desiccants, and that will substantially reduce energy use in that building, existing building. Any more? One more. Oh, can we?
Because I think this question will be more for Prof. Wong. So he has been talking about using urban vegetation for urban heat island mitigation. But from what I understand, although it's good for urban heat, but it is bad for dispersion. So it kind of disrupts dispersion, and it's not good for air quality. So, and the recent study by Winston Chow from Geography Department has shown that botanic gardens actually have worse thermal comfort than other urban areas because there's too many plants. So, how much is the optimal? And I think that's yeah.
I'm really surprised to hear that in the botanic garden, you mean the thermal comfort is getting worse because
of humidity.
Humidity. Yes, like I mentioned that in the case of the thermal comfort aspect, where the humidity becoming too high, above 80% and so on, yes, indeed, the thermal comfort may suffer. But it's actually a trade-off, between humidity, between wind, between shading that reduce the solar radiation. Now you may have a good park, with a lot of vegetation. That may increase the humidity, but if you design a park in such a way that it is well ventilated, now I can say that the thermal comfort definitely will not be an issue there. So therefore you must design in such a way that you have good ventilation, so that the ventilation can sort of minimize the build-up of the moisture. Otherwise, yes, that could be a problem. I mean, we all experience that. If you go into a tropical jungle, for example, you feel extremely uncomfortable because of the extreme build-up of the moisture in that. Yeah, but if you have some good form of ventilation and so on, that thermal comfort could be improved. Yeah. All right. So I think yes, humidity is a problem, but our tolerance of humidity is relatively high. Yeah, as long as we do not reach that threshold level, that may not be an issue.
Well, I'll defend Botanic Gardens. It's open till what, midnight or 11 p.m. and I will wager it's cooler than Orchard Road at that time of day. So take your pick. And on that note, I'll use the session chair's prerogative and thank the panelists, and then we'll turn it over to Andrew for a closing. Are you going to be quick, or should we just move the stage? Okay.
So I'd just like to thank the organising committee once again for putting on a very interesting programme today, a very varied programme, all the panellists and the invited speakers, and to Vero, who sort of commanded the ship very quietly behind the scenes. So I'd like to thank all them first. This is just, for many of us here, this is just the first of 3 days of events. So I wanted just to remind you that we're starting our SAB tomorrow at 9, and that's taking place in the Create Tower on the 10th floor in the Foresight Room. Must be some logic to that. And to say that most of you in the room who are part of Sensam, we've got sessions for the different constituent groups to meet with the SAB. The SAB is going to hear from all the different research groups. The research staff are scheduled at 1:45, and if you're in the room, encourage all your friends to go along. I'm sure the SAB would like to hear from you. Our Singapore partner collaborators are on at 2:45, and the MIT faculty at 4:15. So those are the sessions where collectively those constituent groups can get to talk to the SAB and say how things are going. So I encourage you to participate in that. As you probably gathered, it's been a very busy summer already here in Singapore. We've been involved in a workshop on technology and policy earlier this week already. And I'd like to thank Les Norford, Eric Adams, Vladan Babovic, and Bala, who participated in a very interesting session on that. Coming up in a week or so, we have an environmental health hackathon. And please don't ask me to explain what a hackathon is. This is a program which is going to draw together MIT students and students from SUTD, NUS, and NTU to solve problems, environmental health problems. And that's been coordinated by Stephen Barrett and is taking place on July 5th to 7th. If you'd like to know more information, I'm sure he'd be happy to share that with you. And turning it all the way back to this morning's session, I don't know if Charlie Harvey is still here, but Charlie Harvey's running a big international peat workshop in August, which has sessions here in Singapore and then field trips and so on off to Borneo. If you're interested in that program, I encourage you to contact Charlie about it. And with that, have I missed something?
No, Andrew, you haven't. But just to amplify the hackathon a little bit, Steve and I talked about it there. He would welcome anyone who would like to help mentor the teams or judge their work on the last day or even be an audience to that culminating session. So you can see him or Dr. Ashok here about participating.
Thank you. And with that, I think I'm going to declare the workshop over, and we'll see many of you again tomorrow. Thank you very much.